So our first method is integration by substitution, or we may call it reverse chain rule. Let me write it here. Reverse chain rule. So I want to start from the beginning. So let me remind you some notations and chain rule, of course. So let's say y is equal to x squared plus 5x to the power 100. So this is y. And I need to take the derivative of y function. So right hand side we have a complex function. We have two functions there. So one of them is inside function. Second one is exponential function. I mean the power function, 100. So y prime means dy over dx. So we are taking the derivative of y function with respect to x. So it is a complex function. In order to take the derivative of this function, we have used chain rules. So what was the chain rule? The basic idea was the following. So x squared plus 5x, it's the inside function. So we will call it that inside function u, and u is equal to x squared plus 5x. So instead of x squared plus 5x, you may write u. So our function becomes, look at this, I will write it here, y is equal to u to power 100. Oh, now it's so simple. So is it possible to take the integral of both sides now? Y prime, yes, with respect to u, of course. What's the integral of u to power 100? Who will tell me the integral of u to power 100 with respect to u? Yes?
U 99.
Yes, Hanan. So it's same as x to power 100. It's derivative.
Something to the power of 99, but something goes
in
front.
Yes, you are right. Okay, who will tell me the derivative of u to power 100?
Is it 2u to the power of 99?
Isn't it 100?
Okay, Rehane.
Is it 100 or something? 100 u to the power of 99.
Yes, you are right. 100
yes.
u to power 99. So this is the derivative. But we didn't get our result. What was the question? Find y prime. Here, the question is here. We need to differentiate the function with respect to x. But we got the derivative with respect to u. So I need to do something else. So here, the idea is the following. Dy over dx, we got this. Dy over du. I know that y prime is here. Dy over du, because we took the derivative of y with respect to x. It's okay. So if we take the derivative of u here, this one, with respect to x, so what is the derivative of u with respect to x? What's the derivative of x squared plus 5x? It is equal to, tell me the derivative of x squared plus 5x. It is
2x plus 5.
Yes, 2x plus 5. Nice. I know du over dx. So if we multiply this expression by du over dx, look at this. You will get dy over dx. So that was the idea behind chain rule. So the chain rule, now what is our origin, I mean derivative, what is y prime? So y prime becomes First of all, the derivative of the power function, I mean dy over du, it's 100 times. Instead of u, of course, I will write the x form, x squared 5x 99. It comes from here, this one. Times what? Times the derivative of u with respect to x. So what is the derivative of u with respect to x? 2x plus 5. So this is the chain rule. We are calling this chain rule. And this is the idea of the chain rule. Reverse chain rule is integration by substitution. Now I think you could understand the integration by substitution method better. I will write all of the steps one by one. But don't worry, it will be a little long for the first question. For the other questions, we will do it quickly. So step one. So this is our integral. This is not a basic integral because I have a product, 2x times x squared plus 1, and I have the 100th power, not a basic integral. But anyway, we will use integration by substitution or use substitution method. Step one. First step is we need to pick u for what? To make it easier. So we need to pick u here. So idea is we will write this integral in terms of u, and it will be easier than the given function. So let me give you some tricks here. Usually, so here you need to pick u, but where is u now? Is it 2x? Is it x squared plus 1? Or is it x squared plus 1 to power 100? Or something else?
X,
You may have
x
complex
squared
functions.
Plus 1.
So usually it will be the inside of something. That's the first one. Usually the inside of something inside. Of something. Here the inside of something, inside function is x squared plus 1. Usually it will be the inside function. But if you have, no need to be like that, but 99% it will be like that. If you have a trigonometric function, it will be usually this part will be u. So this part will be u. If you have a logarithmic function, again, it will be this part. So angle of a trigonometric function, usually, no need to be, but 90% it will be there. That part will be u. If you have a rational function, let's say here you have something over x squared something, it will be the denominator. So our denominator will be u, usually. So since we have a polynomial function here, it will be the inside of something. So that inside function is x squared plus 1. So we will call it x squared plus 1 u. So u is equal to x squared plus 1. Nice. So our integral becomes, I will write now the integral again, 2x u to power 100 and dx. But here we have a problem. You need to terminate all x values. So everything should be in terms of u. I have 2x times dx. So I need to terminate 2x times dx. So in order to terminate, or in order to write the integral in terms of u, you need to take the derivative of u here. With respect to, remember the notation, I will take the derivative of u with respect to what? Right hand side I have x with respect to x. So when you take the integral of u with respect to x, what will be the derivative of x squared plus 1? Tell me the derivative of x squared plus 1. Ahmet Kınal, what is the derivative?
2x.
Yes, it's 2x, only 2x. I got this. Nice. So here it depends on you. You may write du, you may write dx. So here I will write du. What is du? Du is 2x times dx. So here I can write du, but it depends on the question. Sometimes you may write dx, no problem. You will get the same result. So look at the function again. So the derivative of u must be somewhere here. I mean, somewhere in the function. So I am looking for the derivative of u, I mean du. Do you see du here? Yes. So this is what the product is. This is du. Look at this. Du is equal to 2x times dx. So I have 2x times dx. So bingo. Now our function becomes, in fact, it was the second step. Let me write step 2 here. Step 2 will be this. We did it. You need to write integral x dx. You need to transform this integral this form. So we need to transform that. So we did it. The original function, it was 2x times x squared plus 1 dx. So we transformed that function. There was a power, I think it was 100. Yes, there is 100. So it becomes u to power 100 times du. Look at this, u to power 100 times du. So this is the second step. Third step is easy. What is the third step? Do integral. Take the integral. So just integrate. Who will tell me the integral of u to power 100 with respect to u? This is a basic integral. So what's the integral u to power 100?
100 u to the power of 99 times.
No, not the derivative integral.
101 over 101.
Yes, 101 and 101 and
Time C plus C plus C.
plus c. Yes. So this is the integral. We have finished our calculations, and the last step. What is the last step? The result should be in terms of x. So the last step is translate back to x. So that's the last step. And that's the easiest step. So just I will translate of the resulting part. So u to power 101. What was u? U is x. U was x squared plus 1. So instead of u, I will write x squared plus 1 to power 101. Sorry, 101 over 101 plus c. So this is the end of the operation. We got the integral of the complex function using integration by substitution. So we won't write all of the steps one by one like that, but it works in this way. First of all, you need to pick u. You need to be careful. Usually, it will be the inside function. It will be the sine of something or cosine of something, ln of something. That part will be u. Or if you have a fraction, rational function, usually it will be the denominator. Then you will write the function. You will transform the function here in terms of u. You will write everything in terms of u. Then you will integrate. Then you will translate. Again, you will write x values. It will be the end of the calculation. So here is another problem. Okay, who will tell me what's u here? So u is, usually it will be inside function, is it? So this is the inside function, as you can see. So it doesn't fit. I mean, if it's not okay, choose another one. But let me write, this is u. So u is equal to x cubed plus 7. Take the derivative of both sides. What is du over dx? Who will tell me the derivative?
2x to the power of 2.
No,
Is it?
3x.
3x squared.
3x squared.
Yes, 3x squared.
Oh,
Nice. That's it.
3x.
Finish. So what's the problem here? You need to transform this integral into u form. Everything should be u. I have 3x squared times dx. I need to write something here. So do you see 3x squared times dx here?
Times dx, you're
Yes.
right.
So du is 3x squared times dx. So our integral becomes u to power 5. So the power is 5 here times du, because 3x squared times dx is du. Now it's a basic integral. What's the integral of u to power 5? This one.
U power 6 over 6.
Yes, u power 6 over
Plus
6
c.
plus
over
c.
6.
Then again, what was the last step? Translate to back to x. So what was u x
So
cubed?
3 to x to the power of 3 plus 7 to the power of 6 over 6.
Yes, plus c. This is the integral. So our integral is 3x squared cosine x cubed dx. So step 1, pick u. Where is u? Which one is u here?
Cosine
the
x cubed.
The derivative of u must be
Is it?
here. What's u? What did you say?
Just use x cubed.
Yes,
Cosine
x
x
cubed.
cubed.
Simeon, you are right. Remember the steps. It will be the angle of a trigonometric function. That's x cubed here. So u is x cubed. Let me write u here now. U is equal to x cubed. Second step. Okay, who will tell me the second step?
Form the derivative.
Yes, I will take the
of u.
derivative. So I will write it in this way quickly. Du will be equal to 3x squared times dx.
dx.
Okay, I got du. So now we will transform this integral into this form. So what should I write? So now 3x squared times dx is together. Together it's du. Look at this. It's given here. So it becomes cosine u du. So what is the integral of cosine u? It's a basic integral. So then we will have this 3x squared times cosine u times dx. But we have a problem. I have 3x squared times dx. We need to find something for that expression. It should be in terms of u. So since u is x cubed, when you take the derivative, so here du over dx is equal to 3x squared. but I wrote it immediately. Du is 3x squared times dx. Did you understand this part? Why du
Yes,
is equal
yes.
to, okay. Then, so I'm trying to find the same expression inside the function. There should be there. I mean, find du or dx here. I mean, 3x squared times dx. Okay, 3x squared times dx is du. So instead of this 2, I will write du. Then our integral becomes cosine u du. Because this product is together, it gives us du. So now it's the basic integral. What's the integral of cosine u?
Sine
Sine u.
x cubed
So sine
plus c.
u plus c. Then translate back to x. It becomes sine
Sine x
u is
squared.
sine
X cubed, sorry.
x cubed plus c. So this
Plus
is the
c.
end. Finish. So this is our integral. If you take the derivative of, if you differentiate this one, you will get the given function. ln x over x dx problem. Okay. Now step 1. Which one is u?
X.
If you say x, it doesn't help us. Then you will get ln u over u. So
X over x.
no,
ln x.
ln x is together.
Will-
ln x.
ln
You will
x
see the
need
reason
to
why ln x
transform.
is u. So let's say u is ln x. We will try. If x 1 over x is u, it doesn't help. If x is u, then ln u over u, it will be the same question. It doesn't help us. But if ln x is u, now you will see the reason. What is the derivative of ln x?
1 over x.
1 over x dx. So look at this. Our integral becomes ln x is u times dx over x. But do you see dx over x here? What is dx over x? It's du. So
Yeah.
our integral becomes u du. So what is u du? What's the integral of u? What's the integral of x? Same. Integral of u is u squared over 2 plus c. So integral of u is u squared over 2. So instead of u, we will write the value of u ln x squared over 2 plus c is our integral. Finish. That's it. So our main idea or the purpose is we want to make it easier. So because of that, we are writing in terms of u. You need to pick u considering that option. You should make it easier. If your u, I mean, you choose something here, x, if it makes more complex and it doesn't, maybe here, if you choose x, it doesn't help. So choose another one. So you will find the correct combination here, u is ln x.